Alright, hi everyone. So this question is asking us to give the structure of the given, and here we have the condensed formula of 2,2,3,5 tetramethylhexane. Now here we are given a condensed formula, and our task is to convert this into a Lewis structure. Now recall that in a condensed formula, carbon-carbon and carbon-hydrogen bonds are not explicitly shown. Instead, atoms in a given compound are grouped together without necessarily showing their bonds. This means that carbon and hydrogen atoms are grouped together, which means that CH₃, for example, indicates that 3 hydrogens are connecting to that specific carbon, and so on. Now, sometimes we come across groups that are written in parentheses, but the meaning of them depends on the context. Parentheses with no subscripts indicates that that is a substituent branching off of the parent chain. Parentheses with subscripts tell you there are multiple branches, and repeating CH₂ units enclosed in parentheses with a subscript n indicates multiple repeating CH₂ units within a parent chain. Now, a Lewis structure, by contrast, showcases all possible bonds and all atoms present within a compound. Lone pairs of electrons and formal charges are also shown. So in considering our given compound, we have 2,2,3,5 tetramethylhexane. So the first thing we're going to do is go ahead and label the carbons in our parent chain. So we're going to start by drawing out all 6 carbon atoms connecting to each other. Now, I made the bonds in between them quite long to make sure that I have enough space for my substituents. So let's go ahead and add substituents. We have 2 methyl groups, that's 2 CH₃ groups, branching off of the second carbon in the parent chain. So that's 2 carbon atoms with 3 hydrogens bound to them. So now on the third carbon of the parent chain, we have another methyl group, so that's another CH₃ group. And lastly, we have one more methyl group on carbon 5. So now that substituents have been added, let's go ahead and add the hydrogens on each of the remaining carbon atoms. Carbon 1 has 3 hydrogens associated to it. Carbon 2 has 0. Carbon 3 has only 1. Carbon 4 has 2. Carbon 5 has 1. And carbon 6 has 3. So now that all bonds have been added, lone pairs of electrons and formal charges are located and calculated if necessary. But recall that hydrogen can only share 1 electron, which means that it can only create 1 covalent bond. Carbon, on the other hand, is tetravalent, which means that it prefers to have 4 bonds in order to remain neutral. And what you'll notice is that all carbon atoms have 4 bonds and all hydrogen atoms have only 1 bond. Because all atoms are in line with their bonding preferences, their formal charges are going to be 0. But just for the record, let's go ahead and recall the formula of formal charge. Formal charge, or Fc, is equal to the number of valence electrons subtracted by the number of non-bonding electrons, that's the lone pairs, and also subtracted by the number of bonds. So this is the formula for formal charge, but because carbon or all carbon and hydrogen atoms are in line with their bonding preferences, then their formal charge is going to be 0. And there you have it. Here is our complete Lewis structure. And so with that being said, thank you so very much for watching, and I hope you found this helpful.